Hello, respected sir, ma'am, everyone. I am VPV Dattaganesh of CSIT with roll number 21951A3327. Today, I am here to present my alternative assessment tool Tech Talk video of subject disaster management. And my presentation topic is about abrupt climate changes near the poles. Now, let's get started. Defining abrupt climate changes. What makes it abrupt? Rate of change. Abrupt climate changes refers to shift in the climate system that occur much more rapidly than typical gradual changes. These shifts can happen within decades, years, or even a single year, catching ecosystem and human societies off guard. Tipping points. A tipping point is reached when a small change triggers a large self perpetuating response in the climate system. This can lead to a cascade of effects that are difficult or impossible to reverse. Examples including ice sheets collapsed and widespread permafrost thaw. Unforeseen consequences. Abrupt climate change events of Abrupt climate change events often have unexpected or severe consequences for ecosystem, economics, and human well-being. The rapid pace of change makes it challenging to adapt and mitigate the negative impacts. Polar amplification. Why the poles are warming faster? Albedo feedback. As ice and snow melts, they expose darker surfaces like ocean water and lands, which absorb more solar radiation. This reduces the albedo reflectivity of the surface, leading to further warming. Albedo is the fraction of solar energy reflected from the Earth back into space. Atmospheric circulation. Changes in atmospheric circulation patterns can transport more heat towards the poles. As the temperature differences between the poles and the equator decreases, weather patterns change globally. Ocean heat transport. Oceans currently play a crucial role in distributing heat around the globe. Alterations in ocean currents can lead to increased heat transport to the polar regions. Understanding this system is vital for our models. Ice sheet dynamics. Understanding instability in melt rates. Basal lubrication. Meltwater at the base of ice sheets can lubricate their movements, causing them to slide more rapidly into the ocean. This process accelerates ice loss and contributes to sea level rise. This is a serious concern for coastal communities. Ice shelf collapse. Ice shelves act as buttresses, slowing the flow of glaciers into the ocean. As ice shelves weaken and collapse, glaciers can accelerate, leading to a more rapid discharge of ice into the sea. This is a crucial aspect of India ice dynamics. Surface meltwater. Increased surface melting can create large meltwater water lakes on ice sheets. These lakes can weaken the ice and contribute to the formation of crevasses, accelerating ice loss. This is a visible consequence of warming. Permafrost thaw. A carbon bomb. Permafrost is a ground that remains frozen for at least 2 consecutive years. It stores vast amount of organic carbon accumulated over thousands of years. As permafrost thaws, this organic matter decomposes, releasing greenhouse gases like carbon dioxide and methane into atmosphere. Methane is a potent greenhouse gas with a much higher warming potential than CO2 over shorter time scales. The release of methane from thawing permafrost could significantly accelerate global warming. The releases of greenhouse gases from thawing permafrost creates a positive feedback loop where warming leads to more thawing, which releases more greenhouse gases, leading to more warming. This feedback could have profound implications for future climate. Ocean circulations, meridian overtune circulation, AMOC. AMOC overview. The AMOC is a major ocean current system that transports warm water from tropics towards the North Atlantic. It plays a crucial role in regulating regional and global climate. Slow down. Recent studies suggest that the AMOC is slowing down, potentially due to increased freshwater inputs from melting ice sheets. This freshwater reduces the density of surface water, inhibiting their sinking and weakening the circulation. Climate impacts. A significant weakening or shutdown of the AMOC could have severe consequences, including cooling in Europe, changes in perceptional patterns, and distribution to marine ecosystem. This could cause massive global events. Feedback loops. Albedo, water vapor, and methane. Albedo feedback. Melting ice reduces albedo, leading to increased absorption of solar radiation and further warming. Water vapor feedbacks. Warmer air holds more moisture. Water vapor is a greenhouse gas. Increased water vapor leads to more warming. Methane feedback. Thawing permafrost releases methane, a potent greenhouse gas amplifying warming. Observed trends. Recent changing in polar region. Sea ice decline. Arctic sea ice extent has been declining rapidly in recent decades, with records lower observed in recent years. Ice sheet losses. Greenland and Antarctica are losing ice at an accelerating rate, contributing to sea level rise. Permafrost thaw. Widespread permafrost thaw is occurring across the Arctic, releasing greenhouse gases and altering landscape. Temperature increase. The polar regions are warming at a rate 2 to 3 times faster than the global average. Global impacts, sea level rise, extreme weather, and ecosystem shifts. Melting ice sheets and glaciers contribute to rising sea level, threat- threatening coastal communities worldwide. Changes in polar climate can disrupt global weather patterns, leading to more frequent and intense extreme weather events. Shifting climate conditions are causing dramatic changes in polar ecosystem, impacting wildfire and biodiversity. As we can see in this pyramid, the topmost level is ecosystem shift, the second level is extreme weather, and the third one is sea level rise. Mitigation and adaptation. What can be done? Net zero emissions. Aggressively reducing greenhouse gas emissions to achieve net zero emission is crucial to slow down warming. Innovation technology. Develop and deploy technology to remove carbon dioxide from atmosphere. Resilience adaptation. Implement adaptation measures to protect communities and ecosystem from the impact of climate change. Addressing abrupt climate changes require a combination of mitigation adaptation strategies. Mitigation involves reducing greenhouse gases emissions to slow down the rate of global warming. Adaptation focuses on preparing for and responding to the impacts of climate changes. individual action matters alongside government policies. As we can see, as day to day, our global climate is getting worse. So we should all move forward to save our global climate. Thank you.